All right, welcome back to another video. Excited to have Joe back on again today. Today, as some of you might have seen, we have a new update V2.3 that has just a whole huge slew of features that we're excited to show off. But in this video, what we wanted to do was to take a deep dive into how these features might be useful in an actual workflow. For those of you who aren't familiar, you can actually look at nanome.ai/blogs. On the blogs site, you can actually see a full breakdown of all of the features that V2.3 contains. So definitely recommend checking out our blog for a full breakdown on that. But without further ado, I'll let Joe take it from here in terms of how we can leverage these features in this workflow.
So for this workflow and like highlighting how we would use Nanome V2 with the new updates, I chose a group of neuraminidases that have, there's two groups. I'm not an expert in this area, but we'll try to show like how somebody might use these, trying to understand how to make a new drug. So the basis for the current drugs are all from group 2 neuraminidases, and we're going to look at these types of enzymes that are from group 1. And group 1 includes things like an avian influenza, which has a pocket that is not found in group 2. So in group 2, this pocket, well, it does exist, it's just not mobile. So we're going to look at that mobile pocket and then see if there's any like new bonds that we can form, any new hydrogen bonds that we can put in there to maybe make a new drug bind tighter. So that's our goal for today. And to do that, we're going to use Mara. So we're going to grab a bunch of PDBs from their IDs. We're going to have Mara set everything up for us, do some alignments, and then send all of that to Nanome V2. And before then, we'll even look at a new preview into V2 from Mara. So from the web, even on your cell phone, you could load your workspace and show a preview of what people would see in V2. Again, on your cell phone, iPad, computer, wherever you're at, Nanome's available everywhere now. So that's pretty cool.
Great, let's jump in.
All right, so let's get started in Mara. We want to download these PDBs and force PDB equals true, which for this tool that we're going to be using, it can download a CIF or a PDB. For the tools downstream, we want to force a PDB, so we're going to do that here. Once we have all those, we want to remove chain, actually, we want to split chain A from each PDB file, and create a new file with only chain A. So then some of these are homotetramers. We don't want all of those. We just want to look at chain A. So we can really easily just have Mara do this for us. And then what we want to do is use 2HU4 chain A only as the reference protein, and all other chain A files as the mobile files to align all of the PDBs. And then lastly, now we have everything aligned, we want to move all of the aligned files to a new Nanome workspace. So we'll ask move all of the aligned chain A files to a new Nanome workspace. Even 2HU4, the reference PDB. And we want to name this workspace Tamiflu 9/29/2025. Then finally, cue this workspace to open in our headsets. Cool. So here we've got a little paragraph, but what we're going to be doing is making a workflow. So we only have to do this once. Next time we want to come back, we can just replace step 1 with a series, or the steps of PDBs that we're looking for, and we can just swap those out with other ones and then reuse this type of workflow with a different set of proteins.
And to kind of expand on that, you're not just doing this big paragraph to make a workflow. You're also showing that, Mara can actually take in multi-step commands, right? Instead of, you obviously with a chat interface, you can do follow-up queries one at a time. But because Mara can actually, understand in natural language what the user is saying and then actually map out the steps, like you could throw this giant paragraph to Mara and it'll do it, as we're seeing right now.
Yeah, definitely. And again, we could do this, not, you don't always know what your plan is going into it. Sometimes your plan's made on the fly. I've done this before practicing for this, so I know what I want to do. And let's go through these steps that it gave back to us, because maybe we'll need to revise it. But yeah, you can either make a giant workflow if you know what that is, or you can start with a small workflow and even add more steps to there as well. So cool. So we had 1, 2, 3, 4, 5, 6 proteins to begin with. So we should have 6 steps that are download. And we do download PDB file to HTV. It's going to force PDB true for all of them. And then it's going to extract chain A from those 6 files. So that should take us to 12, extract chain A. And then step 13 is align all chain A files to HU4, which from step 7, that's the reference. Let's go check from step 7. That is from step 1. So this should be 2HU4. So yes, 2HU4 is what we're using as our reference, but not just the original PDB. It is the chain A only PDB. And the ligands are also attached to that chain as well. So after we do the alignment, where we do that here, then we create a new Nanome workspace with the name that we asked for. There it is. And once we queue this, we'll see over here on the left that workspace name. And then we wanted to move all of those files from Mara into V2. So we're going to have 6 more steps. So that'll be step 14 or step 15 to 20. So that goes all the way through. Those are all moved. And then step 21 is to queue the workspace for opening in XR. So now we can just hit run. We don't want to change anything because that's what we asked Mara to do. So we can hit run. And now Mara will go through each step, each tool run, and give us a very clear input and output for those. Like this first one, the input code to HU4, force PDB true, and anything that's blue is clickable, but as it's downloading, it's going to end up going back and opening up those new ones. But yeah, so this is going to finish all 21 steps, and then we will check back in. All right, looks like we are ready to go. Let's make sure that everything worked properly. So instead of just going into VR first, what we want to do is go to our workspace that was created. And it looks like these files loaded, chain A, chain A, chain A, is what we asked it to do. And now we can see our proteins here. We can see that they do have representations. The pockets are shown as well too. All right, everything is aligned. We've got our ligands in here as well too. You can see our hydrogen bonds. And we also have full screen. So nice, beautiful structures. We can see that 150 loop over here that I was talking about that is mobile and stationary. So it has 2 forms as open and closed. So we'll look at that in VR when we get there as well. But yeah, so cool. But available preview into Nanome V2 on the web.
And so this is right now you're I'm assuming on Windows. Previously, as you might be familiar, we had a Windows desktop 2D version, but this is running on the web. So you could be on a Mac, you can be on an iPad, you could be on your iPhone, you could be on an Android. You can load this 2D preview of the workspace. And this workspace is also live updating as well. So maybe we could see this later, but as Joe updates the Workspace in VR, those updates will be reflected in 2D on the web as well. So really cool that we got this preview working.
Yeah, I mean, we can even do, like we said, something about that 150 loop as well, right? So I think those are residues 145 to 150. Let's just say create a new component for residues. Let's do 140 to 155, just so we get overlap on either side. Create a new component for residues 140, 155 for each entry. So this will create a new component, then 1, 2, 3, 4, 5, 6 for all 6 entries for residues 140 to 155. And then we can toggle that on with, wire, ball and stick, different representations for the amino acids that are there, which will also make it easier for us to find, which region we're looking for when we get into XR. And we can update that here on the web. All right, so it said that it's creating new components. So we can look at residues 144 to 155. We don't want a cartoon, we already have that, but we can show it as ball and stick. And then we can even see right here, we've got that area I was talking about that is this 150 loop. So cool, nice and easy. All right, so let's hop into V2. Welcome everyone, we're here in Nanome V2. When we start in, we started in the room because this was cute. And we have our main menu, but I like to make mine bigger to begin with, so I just resize it like I would resize a protein. I'm also going to lock it into place here and make it a little bit bigger as well. So there's my working area. And we have all of our proteins shown. They're all over here, all superimposed. We can see the pocket, so Nanome V2 will automatically, if there's a ligand, it will automatically show the residues within 5 angstroms of that ligand, and then show you hydrogen bonding interactions and the surface, so you can see the pocket that ligand is within. And also you'll notice that in these hydrogen bonds, we have some that are a dark orange and some are dark brown. The yellow ones represent highly probable hydrogen bonds, and these darker ones are lower probability hydrogen bonds, so things that are just a little further out. But cool. So I think first thing we wanted to do was highlight this 150 loop, which when this loop is open, you can see it here in the green. And this is something that the group 1s have that the group 2s don't have. Like group 2s have this pocket down here, but this loop stays rigid and it doesn't move. Whereas in the group 1s, this is flexible and can move. And as you can see, all of these drugs that target the group 2, they're in a group 1 protein at the moment, but they don't interact really with any of these 150 loops. We do have a little bit of interaction here with these 2 residues, but other than that, this loop isn't really gone after because they didn't know that they should. So what we're going to do is try to see if maybe we can build some of these residues out so that we can interact with this carbonyl here, try to hold it in place a little bit more. And I also found some other hydrogen bonds, like in here we might be able to build if we add like a little phenyl ring with a nitrogen in here. We might be able to get some hydrogen bonding with these arginines. So that's what we're going to do to show off our new builder tool. We'll also use the selection tool, which is new for Nanome, our V2.3. And also we'll end up taking a look at this sequence menu as well too. All right, so to start off, let's kind of hide some of these and just look at them just real quick individually, what we have going on here. So we've got this molecule with a carboxylate at the end. It's got lots of interactions over here away from that 150 loop, which is this down into here, and that's pretty much what you're going to see in most of all of these, is everyone's interacting with this arginine, these residues around. So let's just get into, let's see which molecule we wanted to start from. So by default, if you highlight over any atom, we have little tooltip that pops up. So this is residue BCZ, this is G39, the pink one, and the white one is Dan. There's one more residue, I think. We can also see these if we go to the ligand table, 1, 2, 3. These are the 3 residues or ligands that came in. And I think we'll go after this G39. So if we click that, it's already visible, but we can get a better 2D preview if we highlight over that. But if we go into Builder Tool and G39, then we can see that this one is now represented as a ball and stick, and that's what we're going to be working with. And G39, let's go back and hide some of these. We can hide that. Put this guy. There we go. So now we are to the molecule that we wanted to amend. And this should have a 150 loop shown. Show these as ball and stick. That cartoon. So now we have our 150 loop that we want to bring something over to. Which is kind of a big, kind of really far away. So we're just going to build off of this. We can make an amide bond here, probably. So let's pull up a nitrogen, and we want to go to replace. Right now we start on build, but using our thumbstick we can go to replace, we can edit bonds, or we can delete atoms if we want to. But we want to replace this oxygen with the nitrogen, and then we're going to go back to build, and let's build off of this nitrogen. And if we click and hold the trigger, then we can aim where we want our guides to be able to go. So we're going to aim out this way, get us a carbon. Now we want to add a benzene ring, and we're going to try to aim a little more down towards this carbonyl down here. So we can go into rings. We want a benzene ring. There are other benzene rings as well too, you know, pyrazine, pyrazole, purines, whatever you want. But we're going to click on this carbon, and if we hold, we can aim where our guides go. And we're going to aim down here. We'll try to keep this coplanar with what it was, but maybe we want to point it a little bit out this way. So there we go. We've got a little carbon in there, and maybe we can replace some of these atoms. Maybe we want nitrogens. We can go to replace, see if maybe we pop a nitrogen here and here. If these might be able to get us some hydrogen bonding interactions here. We can move our menu a little bit. Let's actually save this. We'll call that good. We're just going to pop a little pyridine ring on. So we'll save that. We'll go to add new ligand. We can now see here in our hierarchy that we have a new ligand. And we have the color change is subtle, but both of those are there. You can tell because we have a nitrogen and oxygen overlapping. So we can hide that entire site. And what we can do is create an interaction component. And what this is going to do is use this protein, and we're going to select our new ligand. And then we're going to get that same pocket view that we had before. So we'll see all of the residues that are going to interact and any potential hydrogen bonds. So we'll click create. And then now, cool, we have a few hydrogen bonds. Was hoping I might be able to get one of these, but we didn't. But either way, I created 2 new hydrogen bonds, at least one that's interacting with this one 150 loop. And if we wanted to, we could create this same type of workflow with the other ligands that are there. We could delete my failure of making the bonds that I wanted and try to create new bonds that we want, and just use Nanome to design new small molecules that we can go in the lab and make later. But yeah, so there's that. There is pretty much the builder tool. The selection tool, we can select by atoms, we can select by residues, and it's 3D selection. So here we have our sequence menu, and our new, even our new ligand popped up in the sequence menu. But if we wanted to select from here, we could, like maybe we want this 150 loop again, we can start to select in 3D space, and you click one atom and every residue's going to come with as well. So from here, now that we have our new selection, we can see that it's part of 2HU4. We're right here around this 150 region, and we can create a new component. And we can just quickly name it loop. And here we are up here represented as stick. Get that out of the way. And we can change our representation if we want. We can do wire, but these are also going to be hidden by that. So if we hide our residues. Right, so also too, one of the things you can notice that is new in V2.3 is if we highlight over on the component menu on this new ligand, we get this box, like purple wireframe that pops up. So it does the same for any protein, and the name is also on there as well too. So it's really easy to figure out where your where everything is in the space just from this ligand menu. And we can rename it as well too if we wanted to just call it, our first attempt of Lig1. Other new things, so we have the sequence menu. Something that's also really cool from the sequence menu is if we clear this selection, let's go into a different entry altogether. So we'll hide that, hide our ligand. So we've got this one. There's no ligand in here, but we can still create a component. This has our old component that was residues 140 to 155, but maybe we want to use this as a selection. So this was 2HTV. Make sure we get there. Here's our selection here in 2HTV. And from there, we can either add more things, like maybe we want to cut down on what this loop was, and maybe add a little bit more on this side, and then we can update our selection and change this to ball and stick so we can see where it is. So it's really easy to start from a component that exists, expand that component, contract that component, or just alter it to give you what you're looking for. You can also really easily just select an entire chain if you want. So lots of easy ways to get to what you need to in Nano. All right, so one of the last things we'll talk about are annotations. So maybe we want to know what the molecular weight of this compound is because it's important for our conversation. We can show that now. So we can go to our ligand table. This is, let me get out back to my pointer. This is BCZ, which is BCZ here. So we can click on our view properties, and we want to turn on molecular weight. And now we have molecular weight here on our ligand. And no matter how we look at it, we can see that the molecular weight is 324.18. And it's connected to the ligand that we want it to be. As if we were to show a different ligand, which is here, and maybe we even went into position molecules. So we grabbed this, we can see that where the molecular weight belongs is where it stays. So it's really easy to see the difference between those two. And if we go into ligands and we turn on the molecular weight, for this guy we have two molecular weights shown. Different compounds look kind of similar, but still very different molecular weight. And these can be turned on for multiple things. So you can have multiple pieces of information here. If you had docking scores, you wanted to show those would be really nice when you have a series of ligands, and then you can have all of your ligands, superimposed on top of each other as well too. We could also put our protein back because we moved this. So we can reset position and we'll go back into its space that it was at. But yeah, so that's annotations. Turn these off, or just remove all works as well too. Then I left one on. That's why you use remove all. Now they're all gone. So other features that were added is the ability to play back multiple model PDB files. So if I had a very small set of frames, like maybe 50 frames of some motion or some dynamics, I could move those in if each frame was a model. Then there'd be a play button up here so that we could play back through that, but we're gonna have a complete blog and podcast on that ability because it's quite a game changer to be able to see things moving in the virtual space. The spirit of our model playback is to be able to show multiple models in a series of frames. It's not a true trajectory playback. So we do have big plans for molecular dynamics. So yeah, so the model playback is really just to give users the ability to show multiple frames in a series, like an animation, but not full-on molecular dynamics trajectory. So we still do not support TRR or XTC with Nanome V2, but we do support PDB files containing multiple models. Same thing for SD files that contain multiple models within that SD file. You can play those back as well too now. The last thing I want to point out is a thing that we call better far grab. So in V1, or previously in Nanome, if proteins were really far from you, you would have to point your controller at it, and now you can tell that you're pointing at it because there's a frame around it. And if I click grab now, it just comes right to me, which is super easy when trying to deal with multiple protein files. Sometimes you want some things out of your way. Like I turned on position molecules. I want this protein out of the way, and I want to move everything back so that I can just grab this protein. Nice and easy, but I could also just grab this protein. So the ability to use the far grab makes working with multiple files in a world around you a lot easier because you can just push the whole world away from you and then grab the protein that you need. Super easy. So along with the far grab ability, everybody has their different sea legs for VR. And we give users options. So same thing, enable far grab, snap to hand. If you want to turn that off, you can turn that off, and then that no longer just flies right to your hand. You have to bring it to you, which is not a bad thing. Everybody has a different way that they want to interact. I also have allowed two-handed grab rotation on. So this is something that's toggleable. So if I take both hands and I try to rotate, I'm going to be able to move the protein up and down and everything. But if I turn this off, then as I try to rotate with two hands, it doesn't let me do it the same way. All right, well, yeah, so that's it for our updates for Nanome V2.3, and it's been really fun putting these out and watching Nanome grow, the second version grow. I'm really looking forward to what we do with Nanome V2.4.